It was like one thing. It wasn't like like the no, less.
What units is the finals on? The final? Yeah. All. One, two people try to count it, and then nine.
How many units do we have?
I think it's 8 or 9. Maybe 9. Yeah. Quiz next time.
It's like a no harm.
Oh,
Oh,
what happened here? I'm sorry. Oh, yeah, days 1 and 2. So yesterday and today. It's a no harm, of course, as all testing quizzes are next week. Next time I see you, is it Wednesday? Should be on the hub calendar. Yes, that'll be on paper. The following Wednesday.
Bro. Yeah. Thank you. I know that.
We're gonna be using our calculators for the end of the period. If you have your calculator and want to charge it before that, maybe now's the time to go down and do that. If you don't have your calculator, just maybe share with your partner and just take a look.
That'd be great.
Right, it doesn't have, well, we're gonna be using the graphic portion of it. There you go, that is perfect. That's correct orientation. I'm missing lots of test corrections, so if you have some, give it to me, and if you're working on it, please make sure to get them to me by the end of next week. First. Did you finish the warm-up already? Did you ever do a good job?
What is it that you don't?
First, we know that the shape is a circle, the center is 2, -3. And good afternoon, by the way. Happy Friday. This is it, the dessert of your week, huh? Nice. So we know the center is at 2, -3, which means, oh, and we know that the radius is 25. No, it's 5. Okay. So since what is this 2, -3, it's gonna be kind of the bulk of this is going to be in the third quadrant. Is that correct? So when I graph this, I'm going to want to do a fairly good job. So I'm just going to focus my efforts here. Is a point 2, -3 actually on the circle? No, it's the center. So technically, I like to make it an open circle, but if you just made a circle like a dot, that's fine too. From there, how many points am I gonna do to help me make this? 4 points. Did you all do the right 4 points? So up 5, 5. 1, 2, 3, 4, 5. Did I do it wrong? Oh, is this correct? Okay, and then at this point, you just don't make a diamond. You do your best to make a circle. You're probably going to be disappointed because it's tough to draw circles, but just do your best, and that'll be good. Any questions? I have a question for you. Could you find some more clean points, like more lattice points than just these 4, pretty easily? Think about it. How could you do that? It's so easy to go 5 left, 5 right, but some other points. One hint is that the radius is 5, and that's kind of a special number. Think about it. Think about it. You see it? I'm gonna get the other points. Yeah, magic numbers. You see how 3, 4, 5 could help? How many more points could we get with that 3, 4, 5? 8 more points, right? You see them? Find them.
No, because it's, no, it's like, it's, you can go through. Correct. So it's like, there's a circle. And this is. This is.
So if you're running 3, 4, does that make sense? Like 3, 4, 5. Because it's a 5, we have a special relationship here. So 3, I went over to right 3 up 4, or I could find another point. What do you think? Does that make sense? What is center in front 4, 3, 5? We could,
Okay.
sure, I'll do one of those. There's 4. Here's 3, and we know that the radius is 5, so there's our 3, 4, 5. So we're just making a bunch of these. You see what the other ones that we could sneak in there? Just looking for easy triangles. 3, 4, 4, 3. That's looking pretty circular. Where are the coordinates of this point right here? -2, -6. Let's see what happens if we plug that in. Let's see what we get if you plug in the coordinate. You do 3, 4, 5 there. You plug them in. And it's a -4, it's a -3, but you square them. It's not the same when you square them. 4 squared equals 5 squared. And I would expect you to do a good job or a decent job drawing the circle. And if you miss those points on the test or quiz, if this happened to be on it, that'd be fine. I at least want the 4 up, down, left, right. That'd be good. Plus, I want you to recognize the center is the center, or just be able to build around that. So, what do you think about polar coordinates so far? So far so good. Not terrible. We're about to take to another level. We're thinking about some polar equations and make some polar graphs. You ready? Nico, you ready for this? Your seatbelt isn't on. I don't know if you're ready. Oh, I'm sorry. It is on. You prepared yourself. Okay, let's do it. So cheesy. Packets. Let's do this. Yeah, that looks familiar to me. Okay, here we go. Identify the shape and graph each equation on the same grid. Okay, our first equation, our first polar equation is a very simple equation, r equals 3. If r equals 3, what is theta? Anything. You see what that graph looks like? If r equals 3, it could be anything. What do you know about the circle? It has a radius of 3. That's why it's r. So if I were to ask you to graph the equation r equals 3, you would go to this kind of a graph and you put numbers here. Now, since it's polar, we could actually put more points, but that seems like a whole lot of work to me. I'm just gonna eyeball this. Any questions? Can you imagine r equals 2? Can you imagine r equals -3? Is that even possible? R equals -3? It'd be the same, wouldn't it? For r equals 3, we have, do you see how no matter where I go, r is equal to 3? So if r is equal to -3, I'm just tracing the same thing except starting on the other end, right? So kind of tracing the opposite direction, but you're tracing the same path as that equation's taking. So those would be equivalent circles. Go ahead and discuss B. What would that look like?
Or wait, just like here.
Can you show me what it looks like? It is a line, right? What we're talking about is all the points where theta is equal to 5 or 3. So what is r equal to? Yeah, everything and anything. All values are. You just kind of point in that direction. So is it only up though? Is it just here? Is that it? I could go the other direction too? But it's just pi over 3, isn't it? What about, you can't forget about the negatives. They still count. So if we're pointing in that direction, we're talking about negative r, it is coming out the back of it. So yes, it's the entire line, as you suspected. I'm gonna mark this A and B just for us to have something to refer to if we go back to our notes. And as you know, we can convert from rectangular to polar and polar to rectangular. So I'm gonna take this since we're in polar and convert to rectangular. I think you had some of this on your problem set last time, didn't you? Converting from one to the other. How do you convert this to rectangular? Yeah, Amir, do you have an idea? We could do that. Let's do it. I like it. I like it. So remember that r is equal to not just positive, but plus or minus x squared plus y squared equals 3. Are we okay with that? Okay, let's square both sides. Let's simplify this a little bit. So we have x squared plus y squared equals 9. And you recognize this, of course, as the equation of a circle, center at origin, radius 3. Which one is more elegant? R equals 3, so 9. Oh, we accept both. We embrace both. Could you please do the same thing for B right now? It's in polar, can you please rectangular? Did you get it? Were you able to convert? Okay. Amir, what'd you do with this one? Tan inverse of y over x, right? It's rise over run, so we have the yeah. Does that make sense as the next step? So far it's in rectangular, but it's awkward. As it's to take the tangent of both sides, that cancels that tan inverse. y over x equals tan of pi over 3. You're saying tan x, sorry, tangent of pi over 3 is root 3? Is this true? How did you know this? Unit circle. Let's take a moment to appreciate the unit circle. Okay. Root 3, so y equals root 3x. So what we're dealing with is a line with a slope of root 3. Now, one student who pays extra close attention mentioned to me, isn't the way to change from polar to rectangular, I think what we talked about last time, I think I gave you some other things in my other notes accidentally, I believe. Is it here? These. Where is it? Oh. Should we be using these? In general, yes, if you're given r and a theta, use those to get your x's and your y's. But here we were only given an r, which makes these very difficult to use. But more important than this is really understanding this. So since we were given an r, and we want to have x and y, I hope it makes sense. We just use the r squared and we can do x squared get that squared. With brackets in both of them. You didn't have to have the other. So you need to see the relationships. Same thing with the theta. The theta y and x. Sorry about that, tan inverse. Right, theta equals x and y. But we started with theta in this case. We start with just the theta, so we were able to a little bit more easily and familiarly use. Oh, this was actually the rectangular to polar, wasn't it? That's the rectangular to polar formula, but it's just kind of going back and forth. Use what you need to get what you want. Any questions? Perhaps your question is, can we try some more problems? Then the answer is yes. Here we go. Convert to rectangular form, then identify the shape and graph each equation. I'm going to give you a moment to have some fun with this one. Progress here. This thing may happen, there's a problem. Oh, wait.
Because it's R square root. And then we're at. It's R square root X yeah, I'm like, I'm gonna go. Yeah. And. I didn't get. I didn't want to. There's a. You have to multiply by R on both sides. But R squared is equal to 4R cosine X, and then R squared is equal to X squared plus Y squared. And then for it, it's gonna be 4X. Cosine theta is equal to X, R is cosine theta, so you have to multiply by R on both sides. Yeah, so 4.
Oh, yeah.
It's equal to R squared. It's equal to R squared, so that means 4X is equal to X squared. Yeah, and R squared can be changed to X squared plus Y squared.
We'll go over these in about 20 seconds.
Oh, yes.
Oh.
Okay.
Are you ready or you need a little bit more time? A little more time it is.
This gets changed to X minus B squared plus Y squared.
Oh, yeah.
And that's not.
Oh my God.
It has the. Is it
The line, no, it's the
Or
line.
B, I said that.
C is the line.
Tan theta is equal to
Okay,
y.
Yeah, so it like.
So I divided.
For this one, you just drop the.
Or is
part,
X
so that it's
squared
like
plus
a
Y
circle. So
And then cosine of theta.
Or is that or r squared?
No, yeah, that is.
Cosine of theta.
Okay. Multiply both.
So it's R sides.
I did have
Yeah. Wait, so what's And then.
R is the square root of X
It's
squared.
radius too.
Oh, yeah.
Um,
Oh, you should put it all on one side.
yeah, one top, 1 0, and then I can do the square.
That's.
Okay, series 15 seconds.
That's.
Wait, how much you do this?
Okay. Ready or not? Let's talk about it. That first one, what'd you do with the R sine theta? Replace it with a Y, didn't you? Why'd you do that? Because that's the relationship we know, yes. So Y equals -2. Please show me what that graph looks like. Thank you. That is a horizontal line, crosses through that Y axis at -2. So this is the first one, A. B, what do you do? Shane?
So like I said, that R is the square root of X squared plus Y squared.
Okay.
That cosine of theta is X over R.
Ah, interesting.
So I moved the R to the other side, and so that got rid of the square root, because the square root times itself is switch inside.
Oh, nice.
So X squared plus Y squared equals 4X. Then I moved everything to the left side.
But before we get there, are we okay changing just to X's and Y's?
Yeah.
You did a great job, but I do recommend doing it a little bit more simply by, do we have an idea? Multiply both sides by R, right? It'd be just nice to have an R right here, wouldn't it? So last time we, I think in the, up here we squared, or you could square both sides. R squared equals 9. But here, just multiply both sides by R. And Shane, you get the exact same thing. So what you're doing is fantastic. But you can see that this is going to take us directly there without the multiplying now. So of course, R squared is equal to X squared plus Y squared. And this is 4X. And this matches yours, Shane, is that correct?
Yeah.
Okay. And then from here, can you tell us what was your thought process?
I moved the X to the left side to the 4X.
Why did you move the 4X to the left side?
So I could get everything on one side and then square.
Nice. So you already recognize the shape as a
Uh,
circle. Are we good with that? Recognize as a circle. So it means we're just gonna have to put in the form of a circle. So I don't know if you did this, but I'd like to put a big space there so that we could complete the square, which needs to be filled in with 4. Plus 4 plus 4. So ultimately, Shane, could you just read us the final form?
X minus 2 squared plus y squared equals 4.
Are you okay graphing this one? We know the center is at 2, 0, and we know the radius is 2. 2, 0, radius is 2, so oh, it touches the other line. Isn't that pretty? What's the relationship between this circle and this line? Right, the line is a tangent of the circle, isn't it? The ideas will be coming together. Speaking of tangents, any questions on A and B? Yeah, okay. Shane, thank you for your help. C! I need some help from someone whose name is not Amir. Yes, Lydia.
So tangent theta is just y over x, so that we simplify to y over x is equal to 2, and then multiply by x on both sides. You get the line y is equal to 2.
Now, how did you know that tan of theta is equal to y over x?
That was just like one of the things you talked about. If you can go.
Are we good?
It's like,
It's just a relationship, right? You can't deny the relationship. So y equals 2x. I hope we're okay graphing that. Now that first line that we drew is a tangent line. Do you have any idea what that second line with relationship to that circle is called? Remember what that's called? What is it? Secant line. Secant line. Crosses through at more than one point. Something else I want to say about this? Okay, so just final words. When you're converting, everything is right here. If this is a point, you need to be able to get there with either x, y, or r theta in this unit. And I remember that last time when we were converting from r and theta going to x, that's when we used cosine all eyes up here. If we're doing this, we need to use cosine r theta and x. If we're doing r theta and y, that's when it's sine. But for that first equation, where there was just r, the question becomes how do you go from r to x and y? So if you can see that that connection has to be Pythagorean theorem. Or maybe when you're saying how do you go from theta to y and x, that has to be tangent. We can see right there, tangent theta equals y over x. You don't have to memorize it. You just have to understand the relationships and be able to use them adeptly, which is why I give you all this practice. Any questions? Perhaps your question is, can we try another one? Then the answer is yes. It's like your birthday. It may even be your birthday. Is anyone's birthday here? Okay, well, happy unbirthday to all of you. One tool we can use to graph polar equations is a helper graph. Oh, y'all have your seatbelts on, right? You're gonna want to put on your helmets now. Okay, it's about to go crazy. Our goal is to graph it, make a polar graph. But before we do that, we're going to make what's called a helper graph on just our familiar rectangular coordinates. I'm going to replace x and y though with this is going to be theta and this is going to be r. But I'm not going to make a polar graph there. I'm just going to make a familiar helper graph, which means I'm going to draw our normal sine wave, which is going to have an amplitude of 6. I'm going to tell you right now there are 9 tick marks here. So in order to just have enough space, I'm going to say that this right here is 2 pi. And I'm going to break this up into 4 pieces, as always. 3 pi over 2. And you can do this already, can't you? You decide where 6 goes. I'm going to put it here just because it seems like that should be the second one. And once you're done with this helper graph, I want you to put your pencils down. Bless you. Sometimes I sneeze when I'm getting excited about math too. I get it. Okay, you ready? Again, pencils down. I just want you to watch this. I'm gonna get some information from the helper graph. There. Doing great. Get some information from the helper graph. I'm gonna go one quadrant at a time. In other words, I'm gonna go from 0 to pi over 2 first, and from 0 to pi over 2. When theta is going from 0 to pi over 2, do you see that r is increasing from 0 to 6? Now, if it just stayed at 6, I'd have 1, 2, 3, 4, 5, 6. I'd have this quarter circle, wouldn't I? If r is just equal to 6 the whole time. But the fact that r is increasing from 0 to 6, I mean, I don't want to miss, make sure you're looking up here. What's happening is I'm going to start at 0, and as I turn my hand 1/4 rotation, I'm going to open it up to 6. Again, I'm starting at 0. I'm not starting at 6 and ending at 6. Starting at 0 and opening to 6 in that quarter. Which means as I go through here, so this is for the people at home. As I turn through this rotation, 0 to pi over 2, excuse me, the radii are going to open up to from 0 to 6. Do you see what that's going to look like? Something like, well, 1, 2, 3, 4, 5, 6. I know it's going to end here. And as it opens up, it's going to draw a path that looks something like this. So putting you could pick up your pencils once again. So you can see as I do this, r's are going from 0, it's growing, 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 growing up until it gets to 6. I want you to continue the idea that I just started on your graph. One quadrant at a time. So second quadrant, third, fourth, and even onto the 5th quadrant. As you go, check in with your neighbor, make sure that they're happy, healthy, enjoying good things. Really analyze that third
No,
quadrant.
yeah, I think you're right.
Analyze that third quadrant.
0 to 6.
Is that not?
Yeah.
It's like, oh, it's like,
Yeah.
I like this such a
You go. I don't get it.
It's gonna yeah, and then it's gonna do the negative.
So sure, I'm gonna.
I'm seeing some really good ideas. Not all of them are right, so make sure you take a look around at the people around you. If they match, doesn't mean they're both right. It might mean they're both wrong.
Yeah, we got like.
Nice, seeing some good stuff.
One where the third quadrant, yes.
10 seconds. Okay. Second quadrant, pi over 2 to pi. The r's are going from? Is it very obvious from our helper graph that the r's are going from 6 to 0? In this second quadrant here, they're going from 6 to 0. So I want to do the same thing here. As I rotate through this second quadrant, I start at 6 and I'll stay at 6, close to 0. Did you all do that? Completing that kind of ovally looking thing. I think it's got to be a little bit wider. Okay, so we have that. But how about the third quadrant? Yeah, Lydia. 0 to -6. So let's take a look at that point -6. R is -6 when theta is 3 pi/2. Would you just take a look with your partner, where is the point -6 comma 3 pi/2? -6 comma 3 pi/2. Did you find your error? Because a lot of you have some wonky stuff.
And like matches, it matches.
Oh,
This way, 3/2.
It's up there.
What's going on?
It's one that back.
It's like the top over there. On the bottom. Oh. Oh.
Just raise my circle, radius 3.
Oh, so you don't need to like.
Can you show me the graph that results? Nice, yeah. It's just a single loop. Just a single loop. Let's make sure that this makes sense. Get on my polar axis here. Going from 0 to 6 to 0. But here, all the radii are negative, aren't they? So you see what's happening from here to that -6, what's happened? Yeah, it's going the opposite way of the pole and ends up retracing what we've already done in the first quadrant. Does that make sense? So it's still drawing, it's just doing a double coat. And then here I'm going to 2 pi. What's happening as I go to 2 pi? The radii are approaching 0, aren't they? From that negative. And after 2 pi, it's going to go back up to 6, down to 0, down over to -6, and 0. Take a moment to discuss that with your neighbor. Make sure that they're okay, that we have a complete grasp.
It goes.
You in
Wham, wham, wham.
Oh, yeah.
Yeah, get R, takes R sine theta.
Oh, like it reverses. Oh. Okay. If we were to still wide, but it's in those. I still goes like. Yeah. So negative. Oh, because it's here. Negative. So. The higher versus from the sign zero. Yeah. Oh. Higher versus 2, 2 power 2, 3 power 2, back at the top. So like. So like from here, like we're going.
It goes through higher.
It's -6 higher than 2. So like you're going from here to wherever that plotted.
So
And then from this point, you're going from -6. Or to 0,
Think about it.
0. So you just go back down. And then like the sine wave starts going.
Okay, so I'm going to ask you to finish your sentence. And just to kind of explore the shape, someone had the idea of changing it to rectangular, so maybe it's more comfortable. Amir? So you multiply both sides by r, I guess?
Yeah.
Okay. Same thing we did earlier. Yeah, I'm going to do this quickly. You don't have to if you don't want to, but we have x squared plus y squared equals 6 times. Now it's y. So x squared plus y squared minus 6y equals 0. Adding what to both sides? 9. So we have x squared plus y minus 3 squared equals 9. Apparently this is a circle center at 0, 3, radius 3. Does that fit the shape here? It is. It's a circle, not as simply as like just r equals 3, of course. It's been moved so that the center is no longer the origin, but it is a circle. But I like that we could build it without actually seeing, oh, it's a circle. Right? We could analyze using the helper. Any questions? Who gets it like 60% or more? what we've done with that helper graph too. Okay, I know this is a tough concept. Any questions? Perhaps your question is, can we try another one? And so the answer is yes. If your answer is, can we stop here? Then the answer is no. I give you a moment to build the helper graph and to make the graph for this one. We're gonna say 1 minute. I really mean 1 minute and 42 seconds.
Yeah. What you said.
Oh, put it in like
It's like
rectangular, yeah.
Yeah.
I don't even, -7's over here.
And then -7.
But
And
negative
then
seven.
pi is over here, so it ends over here.
All right, goes. Yeah. no.
1, 2, 3, 4.
Did we go that one? I could go just there. And
Yeah, cause.
So one quadrant at a time, guys.
Wait, let me see. Like.
Okay. I'll buy that. I can buy that.
Yeah, I like completely number.
Oh.
Wait, no, you're like,
But
right, wait. Pi over two.
I just bang, bang.
So then pi over two to -7 5. It looks. So wait. Would you just go back?
Triple.
No, but when you.
Well, because like pi is like over here, right?
On the top.
And then like you have like -7 going this way. So you just
I
go
don't, I
back.
don't know. It's where the.
Wait. Here, how'd you do like the pi over two to pi portion?
This looks like a part, so, or is that also?
Like
So
we
I-
got
No,
the
this is
first
just like the
part.
circle outline and then I'm
But-
gonna do it.
Oh.
So let me see.
Like
Making
we
your
got
own.
the
Or
first
bridge.
part.
Yes,
and
exactly.
zero to pi,
Like,
right? Because you're just going from 7 or like 0,7.
We did like all.
To this part.
Yeah.
Yeah, from 7 to 0.
But how many just?
Right.
Direction, it is distance in the direction. of the-
Y. Well, then, and then.
Is in the negative direction. Yes. If this direction is the polar axis, this is positive, this is 0.
Right, like, am I just like?
Oh, so you're saying because 3 pi. It's the negative direction. Yes. Okay.
I don't know. No, like, sine made sense, but now cosine is like, you're not, I don't know.
Does it go under? or against? Good question. Where is the point? Negative 7.
Yeah.
Here. and then- First one, direction of pi. This one. That should be 7. But -7. Yeah, that's not. Or it's.
I said that it's. Very much, so we have.
Okay, folks. How'd the first quadrant go? Is it okay? 1, 2, 3, 4, 5, 6, 7. Okay, this is 9. Are we good with that? Any questions? Does the negativity kind of throw you for a loop? No pun intended. How about we just avoid that negativity and recognize that we could build this cosine backwards, can't we? Until it goes to maybe, I don't know, what would this be right here? Negative pi over 2, should we do that? If you're going from negative pi over 2 to 0, then the radii are increasing from 0 to 7. So I'm focusing right here. Increasing from 0 to 7. Now, if I go back in that cosine here, if I go back in the cosine, here I'm at negative pi over 2, increasing to 0. So I could do it like that. I can forget about all that negativity and just do this, but we have to face the negativity at some point. So what is happening after we get to pi? From pi over 2 to pi. What's happening with all those r's? They're going the opposite direction. Thank you, Nico. Does that make sense? R's are going from 0 to -7. Do you see it opening up to -7 until it lands at -7 right here? Do y'all see that -7? It just retraced what I did from the negative pi over 2 to 0. So it is once again just retracing the circle again and again. And yes, this one is a circle. Any question? Yes, Ria.
I'm not understanding. You're saying that in the second quadrant, it's going from like the pi over 2 to pi, you're going to -7. So how is it retracing it? It's on the opposite track.
Well, you can think about it as retracing it, or you could think about it as drawing it for the first time. But whatever's happening, we're going out the back here. And so as this axis continues, it's drawing points over here until it gets to here when it makes that point on that side. Right, so this is that animation. As it continues, it's drawing points out the back of
That's
that.
negative.
Well, because negative. All these r's are negative until we get to pi.
So if it's a negative r, it's positive coming out.
It's coming out the back. That's what polar coordinates are. R. Good question. Any other questions? Perhaps your question is, can we try another one? We have 2 more, I'm telling you now.
Yeah.
For this one, the sinusoidal axis is extremely important. I recommend you do this. Put a 4 right there.
I can't cover.
You're good now, program.
And I was making set, it's not
Have accent of the points you need to make sure are part of your graph. Make sure those 5 points are part of your helper graph.
Yeah. No, you did. You did. No, yeah. It's put on.
Well, there's one 8.
Yeah. But like, yeah. No, I think yeah.
Yeah, now it's.
I don't even know how you
going 40.
Oh, yeah. It's 5/2, okay.
I don't think so.
Okay, wait. Um. Okay, so we're starting from. And we're going 4.
Did anyone get it yet? Love to see what you got.
Yes.
Like,
Yeah.
I think that's all.
So. You got it first.
No, like I get that on the,
Okay.
this graph still there. Right? Oh my god, wait, yeah.
Perfect. So one trade deed.
Uh-huh.
I forgot how it
I
works.
think.
Isn't that
Is it? Apparently. Okay. So then you. So that's like.
Or is it
here.
like?
6 and -6.
Zero?
Okay, we're cooking.
Yeah. I think
Hopefully that works.
Is no zero.
Yeah.
Because there's the Y row one, right? Like, how would you go zero? Like, yeah, like from 4, like, how would you, do you just like go back?
Yo, it's a hard.
Do you know how to do it?
It's actually a hard. What?
How did you know that?
Or I just like.
Oh, because it doesn't count.
Like, why just like go over? So like, I just like.
Pi,
continue
what,
back.
pi?
Well, that's not hard. But then, like.
Let's take it a quadrant at a time.
This?
Yeah.
I'll give you 10 more seconds to discuss because we got one more to do, and I do want to give you a little time in class to do some work.
Yeah.
If I can get your attention, please. We're gonna take a quadrant at a time. Everyone's attention now.
What?
We're taking one quadrant at a time, which means I'm gonna start from 0 to pi/2. Now, the thing that's nice about this graph is with no negative r value. The smallest it gets is 0. And the fact that r is equal to 0 means at some point this graph is gonna hit the pole. Does that make sense? Because r is 0 at one point, this graph is gonna hit the pole. Just one point, but let's keep this in mind. First quadrant, 0 to pi/2, the r's are decreasing from 8 to 4, which means you start up at 8, then you close to 4. Just what it says to do. Now there's 9 total, so I know it starts there at here. It's gonna end right there. So it's gonna look something like this. And let me just make sure with my polar axis, draw my polar axis, starts at 8 and goes to 4, just like the helper graph is telling me to do. The next quadrant from pi/2 to pi, what happens with the r values? You see they go from 4 to 0? So if we were to stay at 4, we'd have this nice little quarter circle there. But it's not staying at 4. Starts at 4 and closes to 0. You do that? Looks like this. Yeah? You know what it's to do? 4 to 0. 4 to 0. Maybe I was too quick for shit. Maybe it's a little bit rounder. It's finished. I'm seeing it.
Right?
It's just my second.
So that does it retrace itself now?
Going in one direction.
There's no negative.
So you can just keep on going.
We'll see something in every quadrant.
Yeah.
This next quadrant, the r's are gonna go from 0 to 4. Does that make sense? And then in the last quadrant, it tells us clearly that the R's are going from 4 to 8. So and this is all about the polar axis. The polar axis is here now. It's starting at 4 and increasing until it gets to 8 when it closes our shape.
This,
It's like eight.
yeah.
Oh, I'm just estimating here, but I'm trying to follow the helper graph telling me that in this quadrant,
Oh, yeah, yeah.
R's are increasing from 4 to 8. So 4 to 8.
4 to 8. No, but then it's 3 still. No, it's still. No, it's no, it still doesn't.
There we go. This is not a common curve in rectangular. It has a special name though. What shape does it look like?
Six.
Looks like a heart. So hopefully it won't surprise you that it is called a cardioid. A cardioid.
True, but it's not fine. It starts at 9, then it goes like that, and it goes to negative, and then it goes, just goes.
Not putting me on.
But it has to start at
Oh,
5.
does it?
Right?
Oh, it definitely.
Yeah, that's like 0, negative.
Okay.
Yeah, it does. No, it's
Any questions?
times negative. So.
Yes, one more.
9's the top.
Here's our 3. So 6 is going to take us up here to what, 9, negative 3. Oops. Make sure you have these dots on your graph.
Yeah, it's. The science is. I didn't know what you got my socks. I'm done with that.
At least go up to pi. This one's tricky.
It's a little different because it's breakers.
So now it goes up. Oh, I think it should, like it's gonna be like the.
Did y'all do that? 3 to 9,
Yeah.
and then to 3. Are we good with that? So far, just to pi is pretty easy.
Wait.
Oh.
3 to 9 and back to 3. Yeah. 3, 9 and back to 3. And help with the next part. We're not going to do the full quadrant because. Okay, your attention, please. We're not going to do this full quadrant. It's too complicated because we have both positive and negative. And to start here, and I'm going to tell you that this is 7 pi over 6. That's 7 pi over 6. Which means I'm not going to go all the way from pi to 3 pi over 2. I'm going to go from pi to 7 pi over 6. And we could calculate that if we wanted to, but we don't have time. But I'll tell you now, this is 7 pi over 6. And this one, I'm sure you could guess, is 11 pi over 6. But 7 pi over 6 first. I'm going to kind of dot that in. So I'm just going to go from pi to 7 pi over 6. And in that little sector, the radii are going to decrease from 3 to 0. In that sector. So what's going to happen from 7 pi over 6 to 3 pi over 2? The radii are going to go from 0 to -3. Where is that -3?
3 pi over 2, but
3 pi over 2. -3. Do you see what that -3 is, everybody?
you're gonna end there.
And all the points will be expressed. Think about this. All the points will be expressed in the angle that is vertical to this. Okay, wait, this isn't 7 5, this is 7 5 or 6, isn't it? I think I got it wrong. I think I did like that. 13 pi or 12, excuse me. This is 7 5 or 6. I knew something seemed wrong. So I'm going to extend this. Again, all these points will be expressed in the angle that is vertical to this sector, meaning they're going to come here. Do you see them? 0 to -3,
Oh, yeah.
right there. So here I am, 0 to -3. Yeah, it doesn't stop. 0 to -3. Now let's go from all the way now from 3 pi over 2 to 11 pi over 6. All those values are negative, so I'm going to go out the back here and close up to that.
But you don't draw that like little part under the, under.
I've only gone to here. I haven't gone to 2 pi.
But did you like actually draw this part under, like under the, yeah,
I draw, yes.
so that's not, and you also draw it like.
Yeah, this is my 3 to 0. 3 to 0.
Yeah, no, and then the other part is.
Yeah.
Okay.
So
Now 11 pi over 6 to 0, that's a 2 pi, yeah.
presentation of an angle there or a bit?
The direction is an angle, distance in that direction is the R. We have to finish this off, opening up to 3.
No,
Not quite as pretty as a cardioid, is it? The special shape. If you spell it like this, it would be limacron. But this is wrong. There's a little thing under that C, which makes it pronounced like an S. So in English, we would normally say limaçon. I'd like to pronounce it more like the French, limaçon. It comes from the word for snail. I think limace is, or limaz is, no, I don't speak any French, but yeah, so someone thought it represented, or it looked like a snail, some sort. It's a little bit longer than I thought, so I'm gonna have to do the calculator portion next time, but I do want to give you some time to work on the problem, so. I hope that you enjoyed the polar equations, and polar graphs.
No. The hardest thing. Wait till we get to logs.